Hello for all the audience. My name is Meidi Putri Ariyani. I would like to say thank you for coming in my presentation. An honor to meet you here. I will present you my research called optimization model of nurse scheduling using goal programming method, a case study. The outline of this presentation are introduction, problem description, the proposed mathematical model, result and discussion, and conclusion. First is introduction. Hospital always face significant new challenges every year due to increase of health care costs. This causes patients to become aware and critical of the service they receive. To serve patients well, the hospital is always required to improve its quality. The good or the bad, the quality is based on the services provided by doctors, nurses, and other administrative staff. According to Jriana 2015, one of the resources that plays an important role in determining performance and quality of hospital is nurses. This because nurses are directly responsible to fulfill patient needs 24 hours a day. However, situations often occur where the number of nurses available is not enough due to the large number of patients, which can result in fatigue and not an optimal performance of the nurse. So that the problem of nurse scheduling has become a focus in the past few years. Nurse scheduling is a nurse overall work schedule so that it meets job certification requirement and the rules and systems that apply in hospital. This research was conducted at UNS Hospital. The nurse scheduling at UNS Hospital is carried by the head of the room and it's compiled based on template that has been met by staffing department. The obstacle at nurse scheduling The obstacle of nurse scheduling caused by the template only considering the assignment pattern, not considering the minimum number of senior nurses or male nurses. So, the head of the room has to make adjustment to the schedule of nurses manually, and it is still found that the minimum number of requirement of nurses, senior nurses, and male nurses on several shifts has not been fulfilled. The nurse scheduling process also takes quite a long time. The objective of this research is optimization nurse scheduling using goal programming. The position of this research is a model development from the previous paper, which is total this from Azizah and Sharif 2005, assignment of senior and male nurses from a delegate and force 2017, and assigning patterns from Siregar 2015, and Hakim Bakhtiar and Jaharuddin 2017. The second is problem description. The case study is taken in patient department of UNS Hospital. One of specific room in the department is Yustisia Room, which employs 30 nurses, including the senior nurses. The Yustisia Room is a specific room in the UNS Hospital assigned to treat COVID-19 patients. The following regulations are enforced by hospital management and are considered as constraint in the model, both hard or soft constraint. First, a day is divided into 3 shifts, namely morning shift, afternoon shift, and night shift. Second, each shift must have at least a minimum number of nurses required. Third, each nurse should work between a minimum and maximum number of shifts during the planning horizon. Fourth, there is no possibility that a nurse have more than 3 consecutive work days. Fifth, each nurse should not be assigned in a morning shift right after the next shift. Sixth, each shift may have at least one male nurse. Seventh, each shift might have at least 2 senior nurses to be assigned as a coordinator. 8. Each nurse has at least 2 consecutive days off after being assigned several working days. Third is the proposed mathematical model. Uh, Below is index and parameters used in the model. First, I is index for nurses, where nurses numbering index are divided into 2 categories. From 1 to U are senior nurses set, and U plus 1 to I are regular nurses sets. J. Index for days. B. Minimum number of nurses required during each shift. C. Maximum number of nurses can work during each shift. D. Minimum number of days that each nurse should work during the planning horizon. E. Maximum number of days that each nurse should work during the planning horizon. F is minimum number of senior nurses in each shift. Z is the total number of working days that each nurse should work during the planning horizon. H. Minimum number of male nurses. A. Where A is 1 if nurse is male and 0 if otherwise. The decision variable used in this model first is P. P is assignment, nurse assignment to morning shift. S. Nurse assignment to evening shift. M is nurse assignment to night shift, while L is nurse day off. The aim of this model is to minimize the shortage and excess number of total working days, goal number 1, of each nurse during the planning horizon. Moreover, the aim of this model is to minimize the amount of negative deviation of goal 2 related to number of shifts on system pattern. There are 15 hard constraints that use in this model. First, ensure that the required number of nurses in each shift satisfied. Second, maximum number of nurses in each shift. Third, ensure that each nurse must work at least minimum number of working days. Fourth, ensure that each nurse must work at most a maximum number of working days. Fifth, in one day, each nurse might only be assigned to one shift. And so on, and so on. After the hard constraint, there are two soft constraints. First, goal number 1, each nurse is assigned a number of Z working days in one planning horizon, where Z is 17. Goal number 2 is ensure nurses work with the metropolitan rota system, morning, afternoon, night, day off patterns. Fourth are result and discussion. In table number 1, we can be seen manual nurse schedule developed by the head of the room. Meanwhile, in table number 2, can be seen the nurse schedule using goal programming method. In table 3 can be seen the percentage comparison between manual and proposed model schedule. First, the fulfillment of the required nurse in each shift for the manual and proposed model have 100% performance, while the fulfillment of required male nurse and senior nurses in each shift for proposed model schedule showed a better performance. 4 days off in proposed model schedule showed that all nurses have day off already fit the regulation, which is 2 days until 4 days, while the manual one haven't. For total working days, proposed model showed a better performance than the manual one. Last is conclusion. In this paper, we developed a mathematical model to address the nurse scheduling problem in inpatient department, specifically for COVID-19 patients, namely the Yustisia Room at UNS Hospital. The model is formatted using the linear goal programming method with the objective function of minimizing the number of deviation by considering constraints related to the hospital regulation and the specific requirement of nurses in each shift, such as senior nurses or male nurses. Comparing to the manually nurse schedule, the result of the optimization showed all the conditions that need to be achieved in scheduling, such as the minimum requirement for the number of nurses in each shift, the minimum number requirement for male nurses, the minimum requirement for senior nurses, and the consecutive day off requirement can be fulfilled. For total working days, the proposed model can produce a better schedule for regular nurses, which achieve the ideal total working days of 17 days for all regular nurses. However, it has not been achieved for senior nurses due to meeting the requirement of senior nurses in each shift. In addition, optimization model is much more efficient in the scheduling process compared to the manual method. As future research, the proposed model can be expanded to consider hiring nurses if there is a shortage number of nurses in some periods of time. Another direction for further research is by considering nurses' preferences in choosing their days off by adding some constraint. Thank you very much for your great attention. May all those we have shared be beneficial for all of us. Thank you.